All right, so we're going to take a look at scale diagrams and just kind of explain a little bit of what they are and kind of how we can recognize them and how we can use them. So first things first, scale diagrams are what we would call an enlargement or a reduction of and I'm going to say real life object. Okay, so it's going to be like an enlargement or a reduction of a real life object. Now we have all sorts of different things like that, and I'm just going to quickly just sneak in here and grab a diagram I have. And so I have a semi truck here. This is you can tell probably not an actual size semi truck, but it's a model that I got when I was in Chicago. Okay, so it's a model. This is a reduction in size, as a real semi truck wouldn't exactly probably fit in my house, not very well. So this is a reduction in size. It's been made smaller, okay, and it may or may not be to scale. It looks pretty good, but we're gonna just pretend it's kind of a scale diagram or a scale model in this case here. Now, the size that something is, or how much it's made bigger or made smaller, is what we call a scale factor. And so the scale factor is the amount the object's real size has been changed. Okay, the amount of the real size has been changed. And for the purpose of this lesson and really going forward, our scale factor is always a change in length. Okay, it's always a change in length. And so I'm just going to bring my my little semi truck here back. It's a fun little diagram, isn't it? Now, if you look here at the length of the trailer. Okay, now a normal trailer is going to be, I think a regular trailer is like 53 feet or something like that. It could be a little bigger, a little smaller, but 52, 53, something along those lines. This one is not that long, okay? If you really want to know, this one has a length of not even 6 inches. It's like 5 3/4 inches. So it's pretty small. Now our scale factor would be kind of describing how much smaller it has become. Okay, and the scale factor for length is going to be exactly the same as the scale factor for the height, for the width here on top, for the truck, for the trailer, for the wheels, everything. Everything is going to be, if it's a normal one, everything is going to be related based on that scale factor. So let's take a look at a couple of examples that deal with scale factor and how we can describe that. So number one, a fire ant is 8 meters long. A giant model of the ant uses a scale factor of 200. Okay, now this means that it's going to be bigger by 200. Okay, how long is the model of the fire ant? Well, 8 millimeters is really small. It's like tiny. It's like not even a centimeter. Okay, so that's how big a fire ant is. We're going to make a model that is 200 times bigger. So what we need to do is take our dimension of the ant and we need to multiply it by 200, which is our scale factor. Now, you can definitely use a calculator for this. 8 times 200, okay, means that the model is going to be 1,600 millimeters long. Okay, so that's how long the model is going to be. It's all based on the scale factor. By the way, just in case you're wondering here, this is 1.6 meters long. So now instead of being this big, it's going to be about as long as I am tall. So if you can envision me in the classroom, sorry, I'm not in the classroom anymore, but if you can envision that, that is about how long this fire ant, which was that big, is now going to be. It's been blown up quite a bit bigger. Now, what about something made a bit smaller? So let's say we have an F-15 fighter jet, which has a wingspan of 13 meters. Now again, I'm going to use classroom examples here, and the classroom is about 10 meters wide, so this is wider than the classroom. Okay, pretty big. Now if we want to have a model of the jet, and it uses a scale factor of 1 to 100, this means that it's 1/100th the size. Okay, it's a scale factor of 1 to 100. What's the wingspan of the new model? Well, we're going to take the original. Again, it always goes back to the original here, and we're going to multiply it by the scale factor, which is 1/100th, okay, because it's smaller. This is less than 1, so it's going to become smaller. And when we multiply it by that, okay, I'll pull the calculator back here, 13 times 1/100, okay, that means, and let me just get the decimal there, that means that it will be 0.13 meters wingspan. Okay, and this is the same as 13 centimeters if you want to kind of relate it. So that's almost the width of, no, it's not even the width of the paper. So it's about, that big there. Okay, it's been made a lot smaller, right? So it's been made a lot smaller because we have a scale factor that is less than 1. A scale factor of 1 is going to represent something that's exactly the same size as the original. Okay, so if I'm making a carbon copy, so if I'm going to take this piece of paper and I'm going to copy it so I can hand it out in class, I'm going to make a 1-to-1 ratio, scale factor so it's exactly the same size so that you can all see exact same size. If I'm trying to save paper, I might make it a bit smaller. But in the case of a normal book or notes, it's going to be the exact same size as which I'm going to print it off as.